Okay, it's usual to start with thanking the speakers thanking the organizers for inviting me to speak. I think in this case I should thank Lev for pushing me to speak when I have really only a very simple-minded talk to give. And I also, on the same occasion, would like to thank Aharonov-Bohm for plugging our book at the end of his talk, which is okay. Now, what I have to say is only about the Aharonov-Casher paper, and I'm going to say nothing beyond the paper, and everything I have to say is in the paper. It's implicit in the paper. The most I can say is that perhaps I've made something explicit that was only implicit in the paper, and this comes out of a conversation with Yakir, in which I tried to understand something. So in the paper of Aharonov-Casher, there's reference to a kind of duality between the Aharonov-Bohm and the Aharonov-Casher effect, and it's not really defined mathematically what this duality is. In addition, I found it strange that the requirement for the Aharonov-Casher effect that the line of charge be straight is somehow added on or tacked on in the paper. It's not organically, it doesn't seem to be organically related to the duality. And of course, there's the problem that the neutron in the Aharonov-Casher effect is going through a electromagnetic field, whereas the electron in the Aharonov-Bohm effect is not. So I want to show that these things can be understood better. And this is very much similar to Avshalom's thought, so I'll go through it very quickly, which I intended to do anyway. We'll start with in 2 dimensions. So here we have a plane looked at from edge on, and we have an electron, and we have, I'll just call it an electron and a neutron. Well, there could be any charged particle and neutral particle with a magnetic moment. And then we can put the electron in a superposition of 2 states, and then we can also do that with the fluxon or the neutron. And when we do that, because somehow or other we're going to get the electron on either side of this neutron, there's going to be an Aharonov-Bohm relative phase. Oh, yeah, that's right. Thank you, Sandra. This is a spinless electron. Now, this is very simple-minded. I'm going to continue in the sort of vein. We could do one kind of experiment in which Alice measures the relative phase of the electron, whereas Bob measures the position, just as Avshalom said. So Bob finds the neutron here, and then there's a AB effect, and then where he finds it here, and then there's no effect. And we could also do a different kind of experiment, and this is simply a rewriting of the exact same state. I haven't changed the state at all. I've simply rewritten it, but then it makes a different experiment natural, namely Bob measures the relative phase, and Alice measures the position, and then we get that when Alice finds the electron between the neutron states, then Bob sees a relative phase and topological phase, and otherwise he doesn't. Now this is all very this is all very simple-minded and yet profound. The only reason we think it's simple-minded is because of what Yakir, Aharonov, and David Bohm did 50 years ago. Otherwise, we would only see that it was profound. But are these 2 effects dual? We have 2 different experiments which have 2 different results. But my feeling is, from their paper, that this is not what they meant by duality. Correct me if I'm wrong, Yakir. But I feel that what they talked about in this as duality is 2 different physical systems which have some relationship rather than the same physical system which you can measure in 2 different ways. So let's try to go from 2 dimensions to 3 dimensions, and there are 2 inequivalent ways to do that. We can turn the neutron into a flux line, or we can turn the electron into a line of charge. And in either case, what we're going to have to do, the basic unit that we work with is a electron and a neutron in 3 dimensions, and the relationship between them, which is given by this formula, which, by the way, the Aharonov-Casher paper proves 3 times, and then brings an additional proof which is not totally independent of the first 3 proofs, and in the footnotes, in the references, refers to a 5th proof. So this is pretty well covered by the paper. I'll just mention that you can derive it if you simply take the kinetic term for the electron, the vector potential resulting from a single element of flux. This is straight out of Jackson's classical mechanics. And now we add a kinetic term for the flux particle, for the neutron, and make the velocities relative. And this has some this equation, which is exactly this Lagrangian, which is exactly the one derived 3 or 4 or 5 times in the Aharonov-Casher paper, has some nice properties. It's gauge invariant, as it, of course, has to be. It's translation invariant because we've made all the positions and velocities relative. And it's reflective, namely, if we switch the positions and the velocities and the masses, we get exactly the same Lagrangian, which means that the dynamics and the forces will all be the same whether we have the electron here and the neutron there, or vice versa. And from here we can go on to talk about duality. So here is a line of flux and an electron. This is exactly the Aharonov-Bohm effect. And now I will show you that this physical system does not have a dual effect. This is called proof by PowerPoint presentation. I'll just show it again. Sorry. You can't do duality here because all of those neutrons have their spin pointing, their magnetic moments pointing in different directions. And when we try to transfer them to this one poor electron, the electron will get terribly confused. And that's the result. So we can't have duality in this case. Certainly not duality in the sense that it was prepared for us based on this Lagrangian, which links an electron with a neutron. What we can do, however, is have a duality between a straight line of neutrons and an electron, because in that case everything is well defined and the force between the two entities will not change under the dual transformation. And that's really, as I said, very simple-minded, but it explains right away why the line of charge has to be straight, and explains it as a consequence of the duality. And I would say it also really explains why in one effect we have an electric field, in the other effect there's no magnetic field, but in fact there is an electric field. There's an electric field of the passing electron. So, so everything is really quite natural. There's an electric field in both cases. And once we treat these two entities as dual, and each one capable of moving, then there's no particular reason why we should regard the field of the line of charge as being more disturbing or more unusual than the field from the electron itself. So that's really all I have to say, except to thank Yakir, and this is one of Yakir's best modes of explaining things, and that's a chance to thank him and to wish him many more years of explanations and productivity. With the single neutron.
If the wire would be bent, there is some effect, but maybe it's not exactly calculable.
It's not topological.
It's not topological. continuous field. What happens if the spin of the neutron, while it goes around, is made to change?
Still, I don't think that...
Because you cannot do it in an experiment, like in physics.
I have a question. May I get a copy of this picture?
I think it's on the web, but sure. It's actually Lev's picture. So, yeah, sure. Okay.